Hi. So my name is Peter, as been introduced. I work for DeliveryHero since 2016, and yeah, I started iOS development long time ago, and I had the chance to pretty much work on different kind of problem solving, a lot of uh, scaling issues, and so on. And today I'm going to talk to you about one problem that we faced and how did we solve it. Let me quickly take you on an overview of what I'm going to talk today. So I'm going to give an overview about the way we work and how do we do separation of concerns. A second one, I'm going to talk about the problem that we have faced and we tried to solve. Then I'm going to give the exact required solution. Then I'm going to talk about conductors, which is the title of my talk for today, and how the implementation of this conductor was working. And then if we have some time, I will go to a quick demo. Quickly, how do we work? We did our own variation of Viper. I didn't want to say Viper if like some people that loves to stick by the concepts. It's our own variation of Viper where we have our view controllers that gets all the user interactions, all the lifecycle events, and we try to keep always our view controllers very basic and dumb, that we don't write tests to our view controllers. Then we have the presenter, which takes all the signals that the view controller do and forward it to the presenter, which decides which use case to be triggered. And the use case is pretty much inside an interactor. We group our interactors via use cases, and each interactor have one or more data repositories that it's used to pretty much pull the data. Then, like usually, the repositories are an endpoint where we pull data from an API, but maybe it's a database, a file, whatever, a data repository that could retrieve the data. And back to the interactor where it applies any business logic that is needed. Then back to the presenter to build a view model or like just an entity to be passed back to the view to render the needed information. That was all going good, like a good separation of concerns, but the problem actually started to happen when we started to have those complex screens with multiple use cases. And to show what I mean, this is a screenshot of our home page of the screen. And let me list the number. It's not all, because there are some features that are not even displayed in this page, but only in this page you can see that on the top is where the user can change the address or even change the country, as we operate in multi-countries. Here is a tab where the user can select between different verticals, as we are not only delivering food, but we rather deliver some other verticals like pharmaceuticals, groceries, flowers in some countries. Whatever could be delivered, we deliver. Then this section could start a full module of search where user can search up to a dish details level. Here is a quick widget on the active order where you see pretty much how long it will take to get your order, a quick updates about your order, and so on. This is a top list of deals and discounts that are currently active. Then we have a personalized listing where it's a list of restaurants that this user, based on his order history and profile and many other fields, can get a personalized list of restaurants. At here, a user could change between the expedition type, pickup or delivery, where delivery, the food got delivered at your doorstep, or pickup, you go pick up your food yourself from a restaurant. And like demonstrating what I said, like it's not even visible. We have a marketing banners and marketing messaging that our marketing team can show, and also some communication about some events or flood zones where we say like, okay, your delivery might take longer and so on. And last, also one other hidden feature that you don't see here, but it might pop up, some timed offers where for users that on a specific conditions with like order history as well and so on, they would get some offers that's time bound, and they need to place an order within this time, and even much more that are not displayed here. And this screen is pretty much the one that every new experiment that we do, as we are heavily using A/B testing, are started here. So like that's what we meant by a complex screen. It's one screen with a lot of use cases, and all of those use cases are must to be in the same screen. So previously, how it was working, like as I mentioned, like we have our container views, and the container view have a container presenter. And this container presenter inside, or like between the view and presenter, we started to have a different components. And that's how we started to do the grouping for the use cases, where every component is a full view, presenter, interactor, and repository. And with every new feature or every new functionality that we need to add, we keep adding new components. That was so far so good until the point where we realized that the problem is all about communication. Because when something was to happen in the view of component 1, we need to update the view component 2 and component 3 and so on. And it was even harder on the presenter level, where like one use case, when it finished, we need to start another use case and so on. So with this architecture, we had the presenters and views are pretty much tightly coupled to each other, not at all reusable, and the maintenance of this architecture was very hard. So we decided, okay, let's do another level of grouping, and we decided that our views to contain sub-views of each component view, and the same for the presenter. The one container presenter to have a set of sub-presenters for every other component. And that way, when we are talking about the back of the stuff stayed the same, that interactors and repository per presenter. Okay, then the communication, or like on how it works on a sequence diagram, when the view controller, which as mentioned, that now have a set of subviews, needs to communicate, let's say, about any live event like view did load, for example, and the container view passes the signal to the container presenter. The container presenter starts to notify every sub-presenter about the signal. And accordingly, every sub-presenter would trigger the correct use case to start based on the signal that it was received from the view controller. And every presenter, when it finishes, it reports back to the container presenter, which reports to the container view, then update all the sub-views. So far was good, but the problem was more clear when we started to consider the user interactions. So basically, user is interacting with one view exactly. And this one view, in order to trigger the use case in the presenter, we agreed that we split the views in the presenter. So what happened is a view reports to the super view or the container view, then the container view put the signal to the container presenter, then container presenter starts to route the signal to the right presenter or the presenter of the right component. When the presenter got the signal, it starts the use case, go pull the data, apply the logic, reports back to the presenter. And at that point, we needed to do two things. First one is pretty much to update the view, and the view to update the other views if the data that was retrieved by the first presenter is affecting the view, then trigger the next use case inside the second presenter, which do the job, gets the data, updates the super presenter to update the super view, and start the third one, and so on. And on the third one, they're pretty much the same thing. I think there is no slide that would have fit to put every combination of those communication there. And as a result, we ended up with a massive container views and a massive container presenter, and the maintainability of those two classes wasn't at all possible. And we keep adding new feature. We saw the problem. Then we decided to stop and think about it, and we decided that we cannot solve our problems with the same level of thinking that have created them. So we started by putting set of requirements for the solution. And the first problem we were trying to solve is communication. We needed to find a way to allow seamless communication between the components. Second requirement was the separation of concerns. We needed to keep our components as black boxes to each other, that no component is affected by the other components. Third one is the reusability and flexibility of those components. So in many cases, and like the most common example, I would say the order tracking, if you remember from the home screen, is like, I would like to reuse this component the exact same way in other one. It should be 100% plug and play. No more got classes. We really needed to end those like massive view controllers and massive presenters, and have it like all our classes to be maintainable under the size, and no more big classes. And in our team, we pretty much work with the solid principles as like our Bible. So with no doubt, we needed our solution to be conforming to solid. And that was the point we started to think about those conductors. Let me talk about conductors first. Conductors in physics is basically the material that can control or allow the flow of an electrical current in one or more direction, like metal, like copper. Like the copper is the best known conductor when it comes to electricity. The conductor as a word could work also for the heat transfer. And in music, which I like the most, the conductor is a person who conducts the musical group and making sure that every performer in that group of performers can follow the same rhythm. That said, let me talk about what is a conductor in this presentation. In this presentation, a conductor is an entity that's going to be responsible to arrange the communication between different components in one screen. The conductor is exactly the place where the component signal are going to be translated to a common language that all other components can understand and respond to. So let me show how this will work within our flow. We agreed, or as I mentioned, that the view controller would have a presenter, and as we are tending to organize the communication inside the presenter, we will put the conductor as a layer between the presenter and the set of components. So from now on, we are not going to split the component into view and a presenter and the business logic or the model of it, but rather the component will be one unit that from A to Z, from the view till the back end of the stuff, it's all in one place. We're not going to split it over container views and container presenters anymore. And the communication to work that way, when a container view hits the start, or like the container view notifies the container presenter about the start of the screen, container presenter is to start the conductor, and the conductor is to start all the components. And when every component finish what he needs to do at a setup, it will report back to the conductor, which is going to forward this signal to the other components. And this to happen with every component. Component finish reports to the conductor, and the conductor reports to the rest of the component. Then we eliminated this part of responsibility from the presenter. Okay, with user interaction, it will be pretty much the same. A user interacts with one component or one component UI. Component do the job, pulls the data, apply the business case, and reports back to the conductor, which is going to notify the other components that the first component have finished the use case. And the same with every component, the user interactions to be to the component, from the component to the conductor, from the conductor to the other components. Let me dig deep and show how this exactly will work inside our architecture. So we have a presenter, and we have components, set of components, and as mentioned, we would put the conductor between those. Again, as the conductor is tend to organize the communication between or inside the presenter, so the presenter is going to own the conductor. Then every component must define a clear delegate, where it's the entity that's going to listen to all the events that is getting out of the component as a signal. So every component define its own delegate, where the other, or like whoever passed as a delegate, will get all the signals that are output from that component. Then every screen would define a container observer interface or a protocol, where it contains all the signals or all the events that might happen inside one screen. And the conductor to have a list of observers that are implementing this interface. So now, how to get the signals from the component to the conductor? Yes, in an extension to the conductor, we're going to implement the delegate of the component. And whenever we're starting the component, we are passing an instance from the conductor to the component, so the component could signal the conductor about the signals. And how to pass those signals to other components is by the component in an extension to implement the container observer protocol, and then the conductor would pass those signals to the other components. Last, in many cases, we saw that we need to pass some signals to the container presenter itself, and in that case, we can implement the container observer inside the presenter. Then we would get all the events from all components, even to the container presenter, without the container presenter is having a reference to the component. So the user interaction now will be that way. User interacts with a component, component pass the signal to the conductor, conductor notify all the other registered components, which allow a start of a new use case or just updating the data. User interactions are directly to the component, component reports back or signals to the conductor notify other components to start or update the other components. So what we achieved so far is we eliminated the communication part and the communication between the component from the container presenter. Let's evaluate this based on the criteria we have. Did we achieve seamless communication? Yes, absolutely. The presenter is not aware of what components are inside, and it's not the presenter that who decides when should I notify other components. Did we do separation of concerns? Yes, absolutely. Now every component is a standalone unit that have from the view till the business case, and no component knows about the other components. Is it flexible? Not really, because pretty much now we have this big interface that's called Container Observer Protocol. And whenever we need to add a new component, we would need to update this protocol. And then every observer that was registered in that screen will need to get updated, even if it's not needed to get any signals from the other component. Okay. Did we get rid of the GUT classes? Not really. Actually, our conductor became the next GUT class because it is passed to all components as a delegate. Then this conductor is implementing the delegate protocol of every component that we are going to integrate. And as well, it is where all the communication is happening. So, is it solid? Well, it's easy to say no, because we broke the interface segregation principle with this massive interface of the Container Observer Protocol, and we broke the open-close principle with the conductor that we need to edit this conductor every time we're adding a new component. Okay, then that was the start of the next iteration, or like we decided that, okay, when this is not a good enough solution, we need to update it. Taking a look on the problems, our problems were mainly in those two entities, the conductor and this big interface container observer. So we decided that the solution is to split the conductor and the container observer into multiple entities, which we called a communication channel, which should be on a component level defined. Let me give more details. So a communication channel is pretty much required to be one channel per component. So whenever we need to add a new component, we are not going to edit any code, but rather we're going to add a new channel. Each channel is defining a protocol of observers. So instead of we had this container observer protocol, it's every component will define in the channel that's going to pass to it as a delegate its own observers protocol. And the channel to hold a list of observer that implements its protocol. If we took a quick look on the implementation of this, it's very, very simple class with the use of the generic. So we can say that the communication channel is an entity that has a set of observer that all implements this protocol T, and we can register for a channel and unregister from a channel. And by this, what we achieved is we have the communication channel is the place that will get the signals from one and only one component and can forward this signal to all the registered components as observers in that channel. Okay. Again, if we put this into the way we decided to work, we have the presenter with the conductor, and we agreed every component have this delegate protocol. Then the conductor will be split into multiple communication channels. Each communication channel to implement the component delegate message, and every communication channel to define its own interface of observers. So now that the communication channel implements the component delegate, we can get all the signal from the component, and we can pass those signals back to the list of observers in that communication channel. Then the last one is how to get those signals back to the other component is pretty much by every component who is interested to get signals from a specific component to register itself, or the conductor in that case to register it for the communication channel for the components that it's interested to get signals from. Now we can easily see that and one thing back is again the same. If the presenter is interested to get signals from some of the subcomponents, it's very easy that the presenter would register itself in the communication on, again, the conductor to register the presenter into the communication channel of the component that the presenter needs to get signals from. Now we were able to split the communication inside the conductor to be basically user interacts with component, component reports to the one channel which is passed to the component as a delegate, then the channel to pass the signal to all the observers, which is indeed some other components inside this channel. Then those components could start a new use case or just update the views or do whatever an action needed based on those signals. And same on the other components, when the user interacts with the component, it reports to the channel that was passed to it as a delegate, calling the observers, which allow creation or update for a new business case or update the view with the required data. And all of those channels together forms the conductor. Now we can again check if we can, if we have fulfilled all the requirements that we had or not. We agreed that communication is seamless and separation of concerns were implemented. Then is it reusable and flexible? Yes, absolutely, because now components are absolutely anonymous to each other, and adding a new component will require adding a new channel only, and only the other components that are interested into the signals that are coming from this new component to implement the new communication channel observers protocol, so it would get the signals from the new component. But we are not editing any code. Neither the container observer protocol is edited, nor the conductor is edited. No more get classes? Yes, absolutely. Now the conductor will not be modified or changed every time you are adding a new component. The only part that we're going to add to the conductor is the registration of this new component, if needed, to the other component signal, and the registration of the existing component to get signals from the new component. But we're not going to extend it with more components delegate, nor need to edit it. Last, is it now solid? I would say yes. Now the interface segregation principle is kept by deleting this massive interface container observer, and the conductor class is following the open close principle because we are not changing it anymore. I think I have talked a lot. I hope it was clear, and if not, let's see some code. I put this demo project on GitHub, so you can check it whenever you need. And let me check quickly. So in this demo, what we're trying to achieve is this simulator. As the simulator, I used a very simple use case where we have a timer that whenever we click on this component, which is a navigation bar component, or this component, which is a simple banner component, when I click start, the timer starts to tick, and the counter is written here. And if the tick count is odd, it will be blue. If it's even, it will be red. And if I click stop at anyone, it will stop, and both are stops and updated. Okay, let's take a look at the code. So I would start with the components. We have a timer component, which is pretty much just a timer that keeps ticking whenever it receives the method start the timer. And it's very important to see that, okay, the timer component defines what signals are going to be out of it, which is did tick or did stop. Then we have this navigation bar component, which is, here is the view of the navigation bar. And we have a component which is got initialized with the view, or like it's initializing its view. And it requires to have some data where it can pull the information from, which is like, give me the count and is it running or not. And again, each component must define an interface for a delegate for the signals that is getting out. And in that case, we only have one signal that could get out from this component, which is button clicked. Pretty much the same with the banner. It's very simple. This is the data provider where it can pull the data, and one signal to be out, which is defined in that delegate button clicked. I will come to this one later, but for now, let's take a look on the view controller. Which is the container view controller, the one that pretty much contains all of the three components. Nothing about the components is inside, because we agreed that the goal of this is to make the components totally anonymous for the container, and the container anonymous for the components. Same in the presenter, you will not see any references or any classes that belongs to the other components. Components are absolutely plug and play. But what you can see inside the presenter is this home screen conductor. Before jumping into this, let me show you what we meant by the communication channel. So for example, I would start with the timer one. This timer communication channel is pretty much a class that inherits channel of type timer component observer, which is the observer or the protocol that the channel have defined. And you would see easily this protocol is very, very similar to the delegate of the timer. But the point is to keep the separation of concerns up and to eliminate any dependency between the container and the components. We didn't just say that it will be a communication channel of type timer component delegate, but rather define a new protocol, which is exact replica, but now we achieved full separation of concern between the components and the home screen. And on this communication channel, we implement the timer component delegate in that case. So whenever a signal comes from the timer component, which is like either did stop or did tech, we would forward this signal to the list of observers inside a channel. Okay, and the same for the navigation bar channel and the same for the banner component channel. It's pretty much the same. Every channel defines its own observer protocol, and then it implements the delegate of the component that's going to be responsible on the communication of the events or the signals out of this component. And whenever it receives the signal from the component, it will just forward it to the list of observer. Last one I would like to talk about is the home communication channel, which is again because we need to forward those signals of the lifecycle events, or if there was any direct interaction between users and the container view, we can still define a communication channel, which is pretty much for the container view and the components which is interested into getting signals from the home container itself to register itself at. Last thing before jumping into the conductor is we decided that we don't even want to put the responsibility of creation of the components inside the conductor. So we define pretty much a factory for the components, which to be passed to the conductor. Then when the conductor start is called, it's ready to pull the components from, and it's not even responsible on the creation of the component. So now that it's ready, let me show quickly that communication channel, as agreed, is part of the conductor. So it's even like created, not on the init, but it's just defined that the conductor have a set of communication channels that are a part of the conductor. And whenever the presenter calls the start to the conductor, pretty much what happens is first of all, the container the container view needs to get signals from all the components, which is the navigation bar, the banner, the timer. So the first step is that the presenter is going to be registered for all of those, and pretty much every other component based on the need. So the timer component needs to get signals from the banner and the navigation bar, so it's registering itself for those. And that's now where I can come here back and say that whenever we need to register a component to a specific channel, we need to do an extension for the component to implement the channel observer. So basically, the timer component, to get the banner component signal, I need to implement the banner component observer, and every time the button in the banner component is going to be clicked, the component or the timer component is going to get notified, and that's, in this case, it decided to reset the timer state because it's like the button start and the button clicked. And now you can see clearly that nothing else will be added to the conductor. Well, I think that's it for me. I would just would like to say that we are hiring, and if you would like to meet the team that is working with this architecture and ask them more about, is it really helpful? How was this helpful to solve the problems? Please feel free to visit us in our booth. And thank you very much for this chance. It was quite a pleasure. I thank you very much.